In this video, I just want to introduce the concept of artificial intelligence and machine learning to kind of help give some background information. So, first of all, what is artificial intelligence and why do we actually need it? And so, to kind of think of this case, you have to accept the fact that computers are actually really dumb machines. I mean, if you think about it, whenever you write a program, you're giving the computer an explicit set of instructions that it must do and operate for, until the end of the program. And these instructions are very, very explicit. You say, well, let foo equals 4 or something like that. And so it's the instructions that you're giving it are actually really explicit, and they can't be vague in any sense. They have to be very clear. And because another problem with this is that you have to account for every possible kind of scenario in your code. So think of this as being like switch cases or tons and tons of if-else blocks. So when the user gives in some kind of input, you have to do lots of checking to make sure that it's within the parameters of your program, and so on. So this is really you have to account for all these cases when you're dealing with these programs. And again, this behavior isn't really human-like. Humans can deal with vagueness. I mean, they have so much more computing power mentally, and they're able to handle a lot of these cases. They don't have to think about every possible case in order to do, a task, and they don't have to be given incredibly explicit instructions. I mean, it helps, sure, but humans can handle vagueness actually quite well. So that's kind of like the goal that we're trying to get to with artificial intelligence, is to build something that can think and reason similarly to humans. So to begin our story, we have to first talk about good old-fashioned AI. So this actually started during the 1960s, led by Marvin Minsky. This actually happens at MIT, and he actually kind of helped started bringing in. He started like the MIT's artificial intelligence group there, and so the thing with good old-fashioned AI is that it's not really learning of any kind, if you think about it. So the whole point of good old-fashioned AI is it was all about search, actually. And so by search, I mean like things like graph search, and I'll show you an example of that actually in the next slide. There are all these different kinds of like search problems, and pretty much the thing with good old-fashioned AI was, could you formulate your artificial intelligence problem as a search problem? And if you could, then you can use good old-fashioned AI to basically solve your problem. And so there's really no learning that's going on, because in these good old-fashioned AI systems, you're actually just enumerating all. It's kind of like the thing we were talking about with programs. You're kind of like enumerating all possible states, and then you're just searching. Searching isn't really learning. And so we'll see this in the next slide. But yeah, so they had different kinds of graph search, and then they had adversarial search actually, and this was particularly useful for playing games like Pac-Man. So if you remember Pac-Man, there's like a little Pac-Man character, and he has to like eat all the pellets, and while you're trying to avoid the ghosts. And so this is an example of an adversarial search problem, because your goal is not only to eat all the pellets, it's also to avoid the ghosts. And so that you can kind of frame this as like an adversarial search problem. And then there's like other kinds of these they're called knowledge-based systems, where you basically just ask the computer or the computer asks you a ton of questions that you answered, and it would just kind of find an answer. But the whole point is that there's really no learning that was going on, but this is still technically under the branch of artificial intelligence. Anyway, let's look at one of these search problems. So here is just a little crudely drawn map. And so suppose your goal was you're in Seattle and you want to get to New York City, and you're booking flights, and maybe there's these edges between these different cities represent like some kind of cost, like maybe it's airfare, or maybe it's, maybe you want to drive there for some reason, and they represent distances, or different kinds of cost metrics. And so this is an example of a search problem where you want to go from one city to another. This is actually a pretty classic search problem, and you want to minimize the total path cost that you're going there. So you might think, oh well, I can just go from Seattle to Washington D.C. and then New York. That's like like 2 edges, but that might not be the most optimal path. Instead, maybe we can go from Seattle to Chicago to New York City, or Seattle to Chicago to Columbus to New York City, and it ends up costing us less overall than if we went from Washington D.C. to New York City. So this is an example of a kind of problem that we can frame as a search problem, and then we can use old-fashioned AI to solve this using like different search algorithms, depth first, breadth first search, A star, and whatnot. So anyway, so what we discussed was good old-fashioned AI, and as I mentioned, it's more focused on a search than it is on actual learning. So now machine learning comes into the picture, and this is where we're actually taking in examples and learning from those examples. And so this is machine learning is technically a subfield of AI. It's probably the largest subfield of AI, and some people have gone on to call it kind of like true AI or pure AI. And so this is kind of like the modern approach that what people have been doing for at least the past few decades, is you take examples and you learn from these examples, and that way you can have you can generalize better. So I'm going to give you lots of examples of these. And the last point I mentioned, that there are parameters that you learn. You use these parameters so that when you get new data, you can do whatever task you want, whether that be classification or regression. We'll talk about those a bit later. But let's actually look at some of the cool tasks that you can do. So I just looked. I selected a couple research papers that talk about the different cool things that you can do with AI. So I just kind of selected a few papers. So here's an example from the group from the Vision group at Stanford. This was published a while back. What we can do is actually train a network to generate a caption given an image, and note that these captions aren't actually they're not just being retrieved. These are actually being generated. New captions are being generated. And so this is a really cool example of you're taking 2 different modalities of data, images and text, and you're kind of blending them together and to get something like this where you can automatically caption images. Here's another popular paper. It's also colloquially known as neural style. This is where you can take a painting of a famous author, like this one happens to be Van Gogh, Starry Night, right? So you can take a painting like that, and you can take a picture that you've taken, and using this neural style approach, it'll actually change your image so that it looks as if it were painted by this particular artist. And so you can see here's like the picture, and then based on these different reference paintings, we can repaint the picture. This is another really cool example of artificial intelligence. Here's also a really neat example, and this is published again pretty recently. It's called StackGAN, and GAN stands for Generative Adversarial Network. And what this is actually doing, this is doing the inverse of what we saw just a couple slides ago. Instead of going from an image and generating text from an image, this is actually generating an image from text. So you give it like a text description, the StackGAN, and it'll actually generate a picture. And so you can see that here are some of the text descriptions that people have given, and here are some of the images that have been generated. And this last row is StackGAN's result. And some of these actually look pretty realistic. So again, this is one of the cool things that you can do with artificial intelligence. Another thing is called visual question answering, where you have an image and you can ask a question about it, and it'll produce some text result. And so here they actually have a web demo that you can go and upload your own images. So for example, I asked the question, how many giraffes are in this image? And it's produced 3. Another thing I can say, what is the cat sleeping on? And it produces the right text, and so on. This is another example by Google, and this is particularly from their Google Neural Machine Translate group, and this is actually really cool because what you can do is you can take two languages where you don't have explicit examples from, like, say, Japanese to Korean. Instead, you use kind of like an intermediary language, sort of, and then it can translate that without having explicit examples from Japanese to Korean, because it kind of chains them together. It's more complicated than this. I'm just trying to give a top level overview. Okay, and this is probably fairly famous. This was on the news. This is AlphaGo. This is how you can train a reinforcement learning agent to learn to play Go, and it turns out it actually plays it really well, as you've probably seen in the news. Okay, so here are some of the technologies that were used in some of those examples that I discussed. Neural networks, obviously a big portion. I mean, there are different kinds of networks that were used. All the image-based tasks had convolutional neural networks, and all the text-based tasks had recurrent neural networks. And I made a small reference to generative adversarial networks. Well, there's a lot of technologies that are going on but all of them kind of central around this concept of neural networks. So if you have a really good understanding of neural networks, you should be able to at least have a very cursory understanding you can gain a cursory understanding fairly easily of the other kinds of networks, because they all kind of rely on these similar principles. So that's where I'm going to stop this video here. And so just to recap, we kind of discussed a little bit about artificial intelligence. We talked about the old-fashioned way to do it using just search, as well as a new way of doing this using learning. And so we're going to get much more in depth into neural networks.